Hi, hello. In the part 1 video, we have drawn the free body diagram and calculated the values of unknown reactions. And in the part 2, we have seen how to draw the shear force diagram. Now, here we can see how to calculate the values of bending moments and how to draw the bending moment diagram. Before starting the bending moment calculation, let's check the sign convention. Here, upward force on the left of the section will push the beam upward, so we'll get a sagging effect and can be considered as positive. And upward force on the right of the section also pushes the beam upward, which gives a sagging effect, so can be considered as positive. And downward force on the left of the section pushes the beam downward, which gives a hogging effect and can be considered as negative. Similarly, the downward force on the right of the section will give a hogging effect, so can be considered as negative. Now let's do the bending moment calculation. For calculating the bending moment at A, we can consider a section at A. Here we have one reaction moment of 20 kilonewton meter. This vertical force we need not consider because at A means distance from the force to section will be 0. So 21 kilonewton, and since it is an anti-clockwise direction at the left of the section, it will give a hogging effect. So we can take it as a negative bending moment. Now let's move to C. Here at the left of the section we have to consider this reaction moment and force of 8 kilonewton. And no need to consider this force since the distance will be 0. So we will have this minus 21, and this is an upward force at the left of the section which gives a sagging effect. So we have to take it as positive. 8 into the distance of the force from the section, that is 1. So we will get a value of minus 13 kilonewton meter. Now at D, we have to consider this moment and moment due to this force and moment due to this force. So this is an anti-clockwise moment, so we can take it as negative. Upward force at the left of the section gives a sagging effect, so we can take it as positive. So plus 8 into distance of this force from this section is 1 plus 1.5, that is 2.5. And this is a downward force at the left of the section which gives a hogging effect. So we can take it as negative, minus 4 into 1.5. So we will get minus 7 kilonewton meter. At E, you can see at the left of the section we have many forces and the right we have only one force. So let us consider this side. Here 2 kilonewton is a downward force at the right of the section which gives a hogging effect. So we can take it as negative, minus 2 into 0.5 equal to minus 1 kilonewton meter. And bending moment at B is 0. For drawing bending moment diagram, I have drawn a beam line and marked all the points. Now at A we have minus 21 kilonewton meter. Since it is minus, let's draw down 21. Now at C we have minus 13 kilonewton meter. and at D it is -7. And at E it is -1. And at B it is 0. From A to C there is no forces. It is zero load and shear will be constant and bending moment will be linear. Similarly, from C to D there is no load, shear will be constant and bending moment will be linear. From D to E we have a UDL, that is load is constant, shear force variation will be linear and bending moment variation will be quadratic. So we have to draw a parabola from D to E. From E to B we don't have any other load, so shear force variation will be constant and bending moment variation will be linear. This is our bending moment diagram. Thus we have completed the problem. This is the given beam, this is the shear force diagram, and this is the bending moment diagram.